Definition. A function has a local maximum at C if there is an open interval I containing C, so that for all x not equal to C, f of x is smaller than f of C. We call f of C a local maximum. Now, let's this again is a mathematical definition. So if I say local maximum, that means I'm looking at a hump. Right? Like your parabola. Your local maximum would be at the top of the hump. At C means it's going to be at a particular x value. And then they're going to take an interval I around the hump. So if I blow the hump up, which you may feel like doing right now, let's make a big hump. Okay, this is C. I pick an interval around C. All this is saying is this y value is the biggest. Because if you go to the left of C, all the y values are smaller. If you go to the right of C, all the y values are smaller. That's like if you're standing at the summit on a mountain. How do you know you're at the summit? Because if you look around you, everything is below you. And that's all it's saying. It's saying when you're at the tippy top, everything is below you. There isn't anything above you because you're at the tippy top. So it says, okay, I'm going to pick an interval around that hump. And if I look around me, I'm at the tippy top. Everything else is below me. That's what that means. And the maximum value is the y value. So the y value is the max. We'll most normally say it's the y value at some x value. But why would it be the max? Because y is the highest point. I can look down and tell you where it happens, but how high does it get? It's the y value. Now, local minimum is going to be the reverse, right? Instead of a hump, I'm going to make a big valley. And this guy is your minimum, local minimum. And then it says take an interval around, and if you're at the bottom, what should happen around you? Everybody on either side of you is going up, is bigger than you, because you are the smallest of them all. So if you're the smallest, everybody else is bigger. So that's all it's saying. It says on either side of that hump, what you've got is everything is getting bigger than you. That's what makes you the smallest. And that means that this y is the smallest. Now the good news for you guys, when I hit my big math classes, I had to prove all this stuff. I hated it. Had to prove it all. And then you had to use all these general definitions in order to do it. It's like, oh, I hated it. Now, by the way, notice it uses the word local. And the reason for that is that there can be sometimes more than one maximum. And if I think about the valley there is the highest point in the valley, whatever that happens to be. And that would be essentially your interval is the valley. But if I increase my interval to be the state of Arizona, is there something bigger than the humps we see in the valley? Yeah. So there are maximums, but there are some maximums that are bigger than other maximums. So that says local means you're just looking at a region and you're saying who's the biggest of what you see. If you increase that region, you could have more than one max, but there's going to be the biggest of them all. See? Increase it to the whole wide world, right? What we think of, and it's still what's so funny, what we think of mountains in Arizona, are they really mountains? I mean, they laugh at you in Colorado. You know, Camelback Mountain. Really? Yeah. So, you know, so it's a matter of perspective. It's where you are. It's where you are. It's local. That's what it means by local. Now, here's what's fascinating. If you're dealing with a local maximum, I notice that y is increasing until it hits the maximum, and then what does it do on the other side? Decreasing. Remember, because I'm moving from left to right, y is increasing till it hits the maximum, and then it decreases on the other side. And if I'm looking at a local minimum, here y is decreasing, right? There's your minimum, then you're going to have y increasing on the other side. And in calculus, you have ways of showing that without having a graph. The slope, yeah. Derivative. Okay, so here we go. This is where you have to be. Oh, thank you so much. This is where you have to be. Give it to Jean. Thank you. Very, very, very careful about what they're asking and how you write it. It says A, intercepts. Well, I'm looking for x and y intercepts. Well, if here's the x, and here's an x-intercept. And the intercepts look like they're at, and they've given us the coordinate points. What, negative 2.30 and 30. And then here's the y-intercept at 0, 1. B, domain and range. Remember, the domain is the x values. So I start seeing graph at x equal negative 3, and if I go along and I graph, the graph seems to end at x equal 3. That says from an domain standpoint, x, this is a solid dot, is greater than or equal to negative 3. This is a solid dot, is less than or equal to 3. And then it wants the range. And the range is the y value. And I notice that if I'm coming up the y-axis, it seems to start at y equal negative 2. And if I do the graph, it doesn't seem to be anything above y equal 2. So I'll put my graph in a box. This says my y values are greater than solid dot equal to negative 2, solid dot less than or equal to 2. Y. Now if you put an interval notation, you kind of get away with the x and y bit. So if I look at it, that's my perspective. My y values land between negative 2 and 2, and my x values land between negative 3 and 3. Okay, here we go. And C. Increasing, decreasing, constant. Increasing, decreasing, constant. Now, for what x values is y? So x is in control. Y's come in multiples. So I never write down y values because here y is increasing and on this side y is decreasing. So how would you write it? It's not unique because this y value is on the increasing arm and the decreasing arm. So you write it in x's. So it says I'm going up when x is between negative 3 and 2. Negative 2. I'm going up. So up means increasing. And remember, it's going to be an open interval, negative 3, negative 2. Always in number line order. Then this sucker flattens out. And if it flattens out, it's constant. So it starts at negative 2 and remains flat until x equal 0, right? So we're looking at negative 2, negative 2, 0. Remove the evidence. Then I notice it's flat and then it goes up again. And it goes up again means I am increasing from 0 to 2. Now, what we normally do when we write this is we put U. This means or. It's union, it's set notation. And then it says 0 to 2. And then it's going to decrease between 2 and 3. These are x values. That says you give me an x value between negative 3 and negative 2, and the y value will be on the increasing piece. You give me an x value between 2 and 3, the y value will be on the decreasing piece. You give me an x value between negative 2 and 0, and the y value will be on the flat piece. These are always x's. And you talked about the next exam. One of the most missed questions is increasing and decreasing because you write the intervals using y instead of x.